What is the limit of 1 plus x to the 1 over x as x approaches 0? First, we might want to investigate what form this limit is in. There's kind of two pieces here, 1 plus x, and then the power 1 over x. 1 over x, as x approaches 0, is going to infinity, since it's 1 divided by an arbitrarily small number. On the other hand, 1 plus x as x approaches 0 is clearly going to 1. So we do have a limit that's in an indeterminate form, the form of 1 to the power of infinity. I'll leave a link in the description to a lesson where we go over the strategies for solving this type of limit. The strategy we're going to use is to take the natural log of the limit, which is going to let us rewrite this exponent as a factor, thanks to our log rules. One thing I should mention before we start going through that is that this is the same as this limit, the limit of 1 plus 1 over x to the x with x approaching infinity. In this limit that we're doing, x in here is going to 0. In this limit, 1 over x is going to 0, since x is going to infinity. And in the exponent, in our problem, since x is going to 0, the exponent is going to infinity. In this problem, x is the exponent, and it's going to infinity. So you can see they're the exact same limits, just written differently. I only mention that because, as we're going to find out, this limit is actually equal to the number e, and this limit is often given as the definition of e. Let's get started. We begin by giving our limit a name. That's going to make it a little easier to work with. And then, like I said, we're going to take the natural log, which will help us out with this power. So then, let's say we call the limit y. If we take natural log, then on the left, we have the natural log of y. On the right, we have the natural log of our limit. But the natural log function is continuous, so the natural log of the limit is just going to be the limit of the natural log. So we have the ln y equals the limit as x approaches 0 of the natural log of this function. This is where the power of the natural log comes in. The natural log of something to a power is the same as that power brought down as a factor multiplied by the natural log of whatever the base was. So applying that log rule, we have that the natural log of y equals the limit as x approaches 0 of 1 over x, the power that we brought down as a factor, multiplied by the natural log of 1 plus x. But then we could just write this as ln of 1 plus x over x, right? Because we're multiplying by 1 over x. So let's just bring the ln into the fraction and write it as ln of 1 plus x over x. Now you might consider using L'Hopital's rule. If we substitute 0 in the numerator, we have the natural log of 1, which is 0. In the denominator, of course, we would also have 0. So this is in the indeterminate form 0 over 0, thus we can proceed with L'Hopital's rule. L'Hopital's rule tells us that the limit of this fraction is going to equal the limit of the fraction of the derivatives of the numerator and denominator. So the natural log is going to be equal to this limit, but this, by L'Hopital's rule, is going to equal the limit of the ratio of their derivatives. Now, the derivative of the denominator is just 1, so we really don't have to write that. The derivative of the numerator is 1 over 1 plus x. So the limit of this must equal the limit of this by L'Hopital's rule. And at this point, we can just plug in 0 and find that it's equal to 1. But remember, that's not actually the limit we want. That's the natural log of the limit we want. That's ln y. So now we just have to solve for y. Solving for y is a piece of cake. Remember, y is the limit that we're trying to evaluate. We have that the natural log of y equals 1, so we just exponentiate both sides. E and ln cancel out, and we find, as expected, that y is equal to e. And that is the limit of 1 plus x to the power of 1 over x as x approaches 0. Hope that was helpful. Let me know in the comments if you have any questions, and check out my Calculus 1 course and Calculus 1 exercises playlist for more. Links in the description.
Integrity, I'm a secular, anesthetic